Yeah, let's take a look at the 14 and 13 similar, and I did that. This kind of forces us to put together, some things that we've done throughout the semester, and then do some calculations. So the problem reads: Merrill Lynch Securities and Healthcare Retirement Inc. are two large employers in downtown Toledo, Ohio. They're considering jointly offering child care for employees as a part of the feasibility study. They wish to estimate the mean weekly child care cost of their employees. A sample of 10 employees who use child care reveals the following amounts spent last week. So we can download, there's a data file, and there is for yours as well. So we download the amounts. Okay, so it just says develop a 90% confidence interval for the population mean and interpret the results. Okay, so we got to go back and do it. It's not given to us, right? Dang, so we got to go back and figure some of this out. So we do the mean, okay, and I've got that labeled. Then the amount of that particular employee subtracted, or subtract the mean from that, and again, you could go the other way, it doesn't matter. Okay, so equal to this amount minus the mean. Okay, and I'm going to use that one as a constant. Carry that down, there we go, right? And then I take the square of that, this to the second power, boom. I can drag that down. I take the sum of that, which is going to be what my variance then, right? And then my standard deviation is simply the square root of my variance, so equal to this to the 1/2 power. Uh-oh, I screwed something up there. Equals that to the, oh heck, how did I goof? I goofed that up big time, because that's correct. So I got to, oh, I'm sorry, I've got to divide this. Hang on here, I think I did that in a little longer sense, but I've got to find the mean of this, right? And then develop my square root. So I'm sorry, I've got to find the average of this, okay, and then develop my square root. So let me do that. So I think I had it all in one formula is the deal. So it's equal to this divided by 9. Okay, why 9? Because we got to make a adjustment, right? Because we're doing a standard deviation for a sample, right? And so it's our n minus 1. So I'm just going to go ahead and plug that in as 9. Okay, to the, and I've got to put some parentheses in here, to the 1/2 power. See how that works. There we go. Dang, see, I make goofball mistakes like that all the time, and the easier way to do it would have been, of course, to have just come over here and said, I'm going to find the standard deviation, stats, standard deviation of a sample, and capture those, hit enter, and I get the same exact number. Okay, it's nice to do it the old-fashioned way. I hope you guys will kindly show me that so you kind of know how to do it, and hopefully you don't forget like I did. Why I did the sum there, I could also have just done the average there of this. Okay, if I'd have done the average of this and then just taken the square root of that, I'd have been okay. Why I said the sum there, I have no idea. I lost my head. Getting late in the afternoon, maybe I'm getting kind of rummy. Okay, so now I know my standard deviation, I know my confidence level, my S or my N, right? My sample size is 10. Okay, So now I know a lot of things. Now I need to look up my t-value. T, so my degree of freedom is 10 minus 1 or 9. My confidence level is 90%, so let's go take a look. It's two-tailed. Okay, so 0.10, confidence level 90. 10 minus 1, 9, right? 1.833. Hopefully that's what I got here. 1.833, which I just have to enter then. Okay, and then I do my math, right? Where it's plus or minus t times my standard deviation divided by square root of my n. And so here I took the square root of my n, right? I took it times, divided by, I took my standard deviation divided by the square root of n, so I did those things all in one. Okay, let's just go ahead and do that. So it's equal to my standard deviation divided by 10 to the 1/2. Okay, and then I multiply that by my z number, right? And I've just done it twice here, I guess, just to make sure. I think I put in, that's what I did, is I put in the whole long formula here. Okay, and here I just went ahead and said I'm going to multiply this times this, so I broke the formula down basically, and I come up with 3.2126. And so at a 90% confidence level, I can say that the population mean is somewhere, so I got to take it plus or minus this, right? Somewhere's between $95.39 and $101.81. I think your guys' is just very much the same, although you're using a 98% confidence level. Okay, so it's two-tailed, so it's going to be this column, right? Or 0.02 up there is the one that you guys will use.